he will say much more about himself and how starting from Telecom Sud Paris, because he's one of our students many years ago. He finished Telecom Sud Paris, so he will tell us his journey, and of course he will give us some insights about open metaverse. We like that, especially coming from Epic Games. Yes. Please. Okay. Before that, Krzysztof will make an announcement.
Yes. Welcome everyone. So before Marc start, just to that everyone is aware that this all the conference is recorded by Teams, by different cameras. So if you have something against that, so I invite you to quit the room. It's we don't have any other solution, and you will be contacted by email to confirm that you agree that the recordings will be published on the different channels that the conference is using by ACM or by the Web3D consortium. So yes, it's how we will proceed this year. It's the simplest way, but yes, it could be something that you have to agree to. Yeah. So thank you very much.
Good. Let's have Marc directly. Marc, it's yours.
Thank you. Bonjour. Ça faisait 34 ans que j'étais pas venu ici. Ça vous donne une idée de que je suis un vieux. So hello everybody, my name is Marc. Today we're going to talk about the open metaverse. Super happy to be here. Basically, I can give you the summary right up front so that you can go back to sleep if you want to. But really what I want to discuss today is how real-time 3D, which is a new form of medium, is becoming easier than ever to create and more economical, as well as how we're starting to have platforms to broadcast and consume that real-time 3D content. And there is a lot of new capabilities opened by those platforms and a lot of questions also raised by this next generation of platforms. And then we'll end up talking about the role of the web and the role of open standards and all those things which we think at Epic is critical. So as Marius said, I was a student here, and the story is in 1986. The school management was incentivizing us to go and explore the world. So they subsidized a trip to Lyon to a trade show called Imagicad, and myself and a bunch of colleagues from INT at the time, remember, we were programming Pascal on Goupil 3s. I mean, this was computer at the time. And when we went to Lyon Imagicad and we saw the first computer graphics, it was actually a very, very bad movie with Johnny Hallyday called Terminus. And a French company called TDI was doing the visual effects and having 3D software. But that was it for us. We all fell in love with 3D, and we started to do 3D back, very early. So as soon as we left the school, we found the group. Finally, we found ourselves doing 3D, and to this day, some of my schoolmates from that promotion are still working with me at Epic, like Jean-Luc Corentin and a few other people. So, and we have a lot of people here in Paris, like Nicolas Trout doing all the Asterix movies and all this stuff. So there is a very strong lineage between this school and computer graphics in France. So. But fast forward 34 years, and here we are at Epic Games. You probably know about Epic a little bit. We are known for our games, Fortnite, of course, Rocket League, and Fortnite and Fall Guys. We are also the home for Rock Band, my favorite game of all time. The Harmonix team's working with us. Can't wait to see what they do with it. And we're a bit of a special snowflake, a special animal, because we're an entertainment company building technology. We're not a tools company. And we do things differently. I spent a bunch of my career at Autodesk building tools, so I can appreciate the difference with Epic. We basically make the things work for ourselves, and we share it with the rest of the world under what we think is a very fair business model, which is the tools are not paid for, but we ask for a modest revenue share when people ship games or ship interactive experiences, so which is between 3 and 5%. And because Team Sweeney always had this idea that it's also better to grow the pie than to fight with your colleagues to have a bigger share of the pie. And that was true in game where it was a high, a high growth environment. It's going to be true of the metaverse as well, and you will find this philosophy again in the metaverse. So we've built around the Unreal Engine a complete content creation platform that is made available to our fellow game developers, but now to many other industries. I'll talk about that in a minute. And really, Tim's goal is to help build the open metaverse. I mean, Tim was talking about the metaverse at a time where it was not the buzz that it is today. So if you were interested, he gave a keynote on the metaverse at SIGGRAPH 2019. It's still on SoundCloud. It's still a good use of 45 minutes of your time because the vision that Tim outlined at that time remains the same, and he hasn't changed. Changed his vision. That's what Epic is trying to achieve. And so, it's interesting, the word metaverse. I don't like using it anymore. I don't know if you remember a year ago, everybody was drunk on the metaverse Kool-Aid. The stock market was crazy. Every company was worth 100 billions. Fast forward 1 year and we're all, managing with the inflation, economic crisis. And I'm happier today than a year ago. And the reason is now people, again, have sobered up. They're now looking, what does this mean? Next generation of platforms, new form of medium. And I think we are, because there is economical pressure, there is more collaboration than ever in the industry. Because everybody understands the metaverse, like the internet, you're not going to build on your own. So there is a lot of collaboration, and people become very focused because they have to answer their bosses says, hey, can't afford to do everything. You have to choose A, B, or C. And that economical pressure, I think, is the best thing that could happen to us. Because the pandemic get us the hype, but I think the economic crisis that we're going through give us the focus. And as you know, as entrepreneurs, you never miss a good crisis to focus the minds of people. Resistance to change is the lowest through crisis for very, very good reason. So I think what's happening today is very important, and we're building it. And I would say we're building it together. And that's a very good moment to be there. But the outcome, if we do the right thing, are going to be transformative for our lives. I mean, let's put it this way. I mean, we can be cynical about the metaverse, but I think it will have a direct impact on all of our lives, and specifically our kids. But I think it'll impact our lives as well. And I'll speak to that during this presentation. So, and usually one thing we do, and I do, is we go around and ask people, what are you going to do about it? You have to do something and around the metaverse because it'll be transformative for companies and for consumers. And so, we all have to think about it. So the basis is, the current generation of the internet was born out the commoditization of digital video and digital imaging. I believe, my thesis is that, and it's pretty shallow, it's not a controversial opinion, is the metaverse is built on top of a new form of media, which is real-time 3D. Real-time 3D has been pioneered for the past 25 years ago, but the games industry, you all remember Doom and Unreal Tournament and all those things. But, in 25 years, we've made progress towards making real-time 3D a medium that can be consumed by the masses. And why is this medium so important? Because it brings two things that digital video does not bring. Number one, it's interactive. Everything can be customizable and it becomes an active experience. And number two, you can have multiple point of view in a 3D world, and most, if not all 3D platforms will be multi-user. And so the experience is social and participative at the core. So I've got something that's interactive and something that's participative. That's what we need. Our kids, they will always watch movies, but our primary medium will not going to be video anymore because you can interact with video and it's linear, and it's not and it's a solitary experience. So I do believe that, fast forward a few years, real-time 3D will be a very, very prevalent form of media, something you can. It's hard to imagine, I understand, because it's clunky, it's difficult. WASD, nobody understands it. Spatial audio, it's a mess. But remember, when I was a student here, we were talking about, video conferencing as like science fiction. Okay, now people walk in the street, I actually saw it in Paris. People do FaceTime on the streets now, it's crazy, right? The cars don't pay attention to people here. But it's going to be the same, just like, we had the Palm Pilot to iPhone continuum. We are at the very beginning of real-time 3D. So, you have to give us some time to make it work. But I think it's the most promising. And once it's going to work, there will be no turning back. It's going to be huge. And the other thing about real-time 3D, which is interesting, is that, yes, it's the promise of the metaverse. But, over the past 5 years, the work we did at Epic, we've proven that real-time 3D and game engines are the most efficient way to create traditional form of media. Synthetic photos, movies, and all of that content can be done much better using game engine technology that it was done with the old pipeline. I'm the old generation. I was part of the Jurassic Park experience. We created visual effects movies back in 1992. It was a mess. Now with the game engines, we have an integrated pipeline. All the tools are in one application. It's open. You can go and, using open standards like GLTF, Alembic USD, you can work with multi-tools, but you have fundamentally a much simpler, more efficient pipeline. And real time is what people need, because your decision is instant. Creative process is highly iterative, so you don't want to wait for rendering anymore. And so the value, that's why you see so much adoption today, because even nobody knows the metaverse is going to be, but people can pick up the technology and deploy it to do synthetic photos for marketing. If you go to a car company's website, you will not see a photograph anymore. It's all synthetic photography. Same for the IKEA catalog, now done with game engine technology. So there is a lot of value in deploying the technology today and getting ready for the future. And I'm not going to do a commercial, but pick up UE5. We have real-time photo, real-time global illumination. With our Nana virtual geometry system, we can infinite amount of geometry. I mean, the technology has made a lot of progress. And one of the things that is at the heart of the strategy of Epic is, in the spirit is we want to accelerate the commoditization and the adoption of real-time 3D. Because the faster it happens, the bigger we have an opportunity for Fortnite. That's that simple. And therefore, we look at the Unreal Engine as the tool. It's not a tool for us to make money. It's a tool to accelerate the commoditization of real-time 3D, and a tool that's going to help us, that's going to create the opportunity for Fortnite. And so we've been working in a number of things, a lot of dedicated tools to solve some very hard problems, like creating entire new worlds, entirely new biomes. We have a lot of work, going on with Quixel and reality captures, objects. We have the biggest marketplace with Sketchfab. We have like 10 million people sharing and downloading 5 million objects. So we're starting to see an economy and an interoperability around digital goods. And then characters, stories needs to have humans that we can relate to. So we have our meta-human technology. That's very important. All of that integrated into one tool then can cater. The same tool can do the linear content, can do the photos, the movies, and can do the games, and hopefully some of the web deliverables. And then it also comes with, online services so that you can actually do multi-user experience. So we have a comprehensive solution that we've been assembling over the past few years. And one of our goals is to make it easier than ever, as I said, and so because we're in France, I'll pay an homage to our team in Strasbourg, who's building a tool called Twinmotion that if you've never done 3D, it's a tool that's made for non-technician. Unreal Engine can be a little bit daunting at times. It's complex. It's a tool for the pros. Want to do AAA games, perfect. But if you want to kit bash your world together and do something in 3D, Twinmotion is your tool. But I'm going to show you, it's built on Unreal here in France, in Strasbourg. I'm going to show you like 90 seconds of what you can do with it, that it sets the bar of what we think real-time 3D should look like everywhere, including on the web. And music. All of that content is basically GitHub sharing of using data just and the Yep. Good. And easy. That's in motion, made in Strasbourg. So the other thing to understand is one of the revolution around content for that, which is going to enable the metaverse, is assets can be reused. Finally, we've been wanting to reuse assets forever, but now again with the kind of represent that we have, the kind of data representation that we have, we can actually start to create assets that are high fidelity enough, you know, for movies and would work, you know, in a web browser or a phone as well. So, and it's a lot of technologies, a lot of complexity. If you take our meta-human characters, you can have the fully detailed meta-human, you know, on a PS5 looking photorealistic, but the same character automatically could be loaded on the phone and with a much degraded, automatically degraded representation is still gonna show you as much as the character of the platform can do. So those kind of technology to adapt the content to the platform are critical. And, you know, it's not like video playback. When you play back 3D, you have a lot of constraints. It's much more complex than anything we've done so far. And so you need those mechanisms to simplify the sharing and the representation of the assets. It's not just formats. Okay, you know, we already have problems with pixels in multiple formats. In 3D, we have a lot more dimension in terms of resolution, in terms of LODs to manage. But the promise, and that is starting to be used by many companies, the best example is probably, you know, the Star Wars franchise, where they use Unreal Engine for virtually every one of their deliverables. They do the VR, they do the theme park, they do the TV shows like The Mandalorian, and they do the previews of the movies, and they do some shots of the movies. So it's becoming a reality. And when you see Darth Vader from one product to the next, it's likely coming off the same set of geometries. And then there is something that we are witnessing, we don't fully understand. It's AI. You know, and AI is going to really help us make content differently. First, I don't know if you noticed, but you know, in 2018 we had the first accelerated ray tracing card, and the progress has been amazing. And I don't know if you remember, but we waited until 2006. You know, we started visual effects in 1992. First ray trace movie was Transformers in 2006. It was a very long time. And in 2018, you know, we get hardware ray tracing, and suddenly things are fast. And the secret behind this, and what NVIDIA, you know, we have to give them the credit, is this notion of AI denoising. They realized and they figured out that it's much faster to guess the neighboring pixel than to compute it. And therefore, you know, the AI is actually accelerating the acceleration. So you get the natural Moore's curves, it gives you a lot of power on the hardware. And then you got those software tricks that, you know, that even accelerate. So AI denoising is well known now in the new generation of car. They've got DLSS3. When they use motion flow, they actually guess entire frames. They're not guessing neighboring pixels for anti-aliasing, they're guessing entire new frame using motion flow technology. So I think we have to be a believer in those things that we're going to get. The level of photorealism we're going to get is in real time is absolutely mind-boggling. And then we use AI to assist humans and to augment the creative capabilities of human. You take our meta-human product, we use machine learning techniques that will prevent you to create a character that's not plausible. It's like we use machine learning to put a ring fence around the uncanny valley so that you cannot get into it. And that means that you can create a plausible human now. 3 years ago, you had to commission a vendor and pay $500,000 to get a digital human that's plausible. Today, you can fire your web browser and go on our website and do it on the web. So we have a lot of that happening, which is going to further accelerate the democratization of creation, 3D creation. And finally, generative AI. You all know about Midjourney and DALL-E 2. It will happen to 3D. One thing we're learning is we want to know who owns the data that are used to train those models, because the outcome is a remix of the data. So it's a developing story, you know, from an IP perspective, from a technology perspective. It's a bit harder to do in 3D, but I'm convinced it will happen. I'm convinced people will learn, to pay for the data set that they use to train their AI, and fundamentally we'll have a new generation of tools so that 3D get accessible. So I hope at this moment I've convinced you that, real-time 3D is a powerful medium, and that it has a chance to, it's hard, it's complex, but it has a chance to be available to many, many more people. And again, we're only starting, so there will be more coming. And it's a real revolution because the cost is completely, the economics of creating the content is completely changed. Some numbers to prove this point. We always said AAA game used to be the hallmark of proprietary game engines. Now on the PS5, half of them are done using Unreal. You heard about the Mandalorian. Here in Paris, we create those gigantic aquarium of LED screen. We do virtual production. We basically generate the backgrounds in real time, and we film the LED screen. That's called virtual production. There are 300 stages in the world right now. It completely changed the economics of visual effects. Mandalorian was the first production doing like this. It was basically 10 hours of Star Wars movie content for the price of half episode 9. So a real dramatic change in the economics. May not be aware that the animation, we were at Annecy earlier in the year for the animation festival. People have adopted real time very, very fast, but it's also there in architecture, visualization, architectural visualization, smart building. Interestingly, embedded systems are adopted game engine technology too. Unreal powers the dashboard of all the Cadillacs now, the new Ford Mustang, the Rivian, because the visual language of video games and the technology of video games, because it's embedded, it runs on this. They have the same CPUs as mobile in the cars. It's perfect to to interface with the complex objects and a complex and intelligent object. So I believe that vehicles is it's the tip of the iceberg where, we develop a next generation of user interface to manipulate a complex vehicle, but we're going to have a lot of complex and smart objects in our lives, and so we do expect to see the game engine technology play a big role there in the user interface of those complex objects. Fashion is an interesting one. We're interested in the metaverse, but we haven't solved it. Are there any researchers in the room? Who wants to be a billionaire? So solve the cloth stimulation problem, because we can do humans and the skin at a level of detail that's actually incredible. We can model muscles and everything, but we cannot put a t-shirt on anybody. We cannot put a jacket on a t-shirt. That is a completely unresolved problem today. And come on, it must not be that complex. Multi-grade physics in real time, 16 milliseconds per frame. It probably can be done. But even though we cannot have an accurate digital twin of a piece of garment, it's huge momentum in the fashion industry. And I think the other part that is going to be transformed is music consumption. It makes so much sense for artists not only to create their music, but to create the world. This goes along with it, online concert and everything. This, you don't have to drill. I'm going to skip another piece of eye candy, a little bit behind the curve. You can check, or maybe I can show you a little bit. I think. So that's basically the section. So we have tools, we have a new form of medium, and now we have platforms. We have platforms that allow the sharing, the publishing, and the consumption of this real-time 3D content at scale. Those platforms, carry the benefits of the medium. They're social, interactive, participative. I think they all offer a co-experience, which is a very important concept, because everything you do with your friends, your colleagues, or your family. And co-experience can be called collaboration in the enterprise. And I think we have to talk about VR. I think for me, the big prize of VR is co-presence. VR is not a requirement to consume interactive content. We can consume interactive content in a browser, and actually, I think the browser, I'll talk about that later, is the place when we should be consuming interactive content. But if you want the experience to be immersive, you can use some of those devices. And I think the value for me would be that notion of co-presence. And even people may not like Meta, but I think Mike Abrash at Reality Labs is one of the leading scientists, and he's leading a team developing this sense of co-presence. And the goal is to be, virtually with someone and have the same sentiment, the same feeling that you are in the room. Like I can read your body language. If you become skeptical, and I see something, I see your facial expression, I see your body language. You cannot do that on Zoom. So VR will give us co-presence. It may take 10 years, by the way. But I think that's going to be the value. It's going to be hugely important because that's going to take away distance. Through the pandemic, my mom is in Paris. She's 86-year-old. I could not see her for 2 years. Even though we talked on Zoom, when I see her, and I was there, weekend to see her, we do something together. We go to the Louvre, we go see something. I do believe that, VR will give us those shared experiences, and it will allow us to have the quality of an interaction that, you can have. Despite the distance. So it's going to be huge. It's going to be a perfect augmentation of our social life. I know we like to associate VR and Metaverse to dystopian concept, but I'm an optimist, I'm sorry, and I do believe that I would have loved to have VR, during the pandemic to spend time with my mom, which I was not able to do. So I think it's very important, this notion of co-presence, but give it time. It's not going to happen overnight. It's probably a decade away. So those platforms, they're pretty complex. I mean, it's going to be, if you want to create a real-time 3D platform, you need a bunch of components. You need to create content, you need interactivity, you need a social graph, you need to have friend systems, you don't want to be isolated. You need discovery, commerce, persistence. So it's not everybody is going to do that, and then you need this kind of quality of content as well, because if it doesn't reach that bar, nobody will want to consume it. So we believe at Epic that Fortnite is one of those early versions of the metaverse, and it's the same. It's not exclusively Fortnite, and you see the platforms coming from the game industry like Roblox or Minecraft or PUBG are the first platform to have all the critical mass of those components and to offer those experiences. Now you have 3D. You have 3D platform coming from other environment. Social media companies are building 3D platforms, primary Meta with Horizon World. And there is a gazillion platforms on the web as well that are being built right now to provide social 3D. It's not a foregone conclusion that the games guys will win. They happen to have a head start, a 25-year head start, but I think the race is on. We at Epic, we think that the games will win because social 3D gaming, social on its own, supporting interaction is one thing, but you want to do something with people, right? So, you don't want to stick at yourself, in the eyes, and that's why social gaming is such an important concept, and I think will at least propel the first generation of the metaverse, if not be, the right thing for the long term. So, but we see those gaming platforms like Fortnite or Roblox. They are a good example of what the metaverse can be, but there will be a lot of others. And come back on Epic. So what we're trying to do, our strategy is all based on the Unreal Engine and turning Fortnite into a platform. So you may or may not know that today, half of the hours played on Fortnite are not played on games created by Epic. People play their own games. Fortnite Creative is a platform when kids can create their own games, a little bit like Roblox. And it's already half of the hours from Fortnite. Then we had a partnership yesterday with Ralph Lauren. Brands wants to be associated because they give them, new forms of engagement. So it's difficult to predict what those platforms are exactly going to be, but it's not just to play battle royale. I mean, they're going to go way beyond those capabilities and going to enable new commerce opportunities. So I'll come back on some of those opportunities. Before I want to say this, because it's very important to us, is our aspiration. If we have our way, we want the metaverse to be open, fair, safe, and social. I'm pretty sure if somebody had written a slide about the web 25 years ago, that's what they would have said. These are not revolutionary concepts, but they are really things that we care a lot about. And if you see the decisions made by team, hopefully you see a consistent pattern that leads to that. And again, just quickly, opportunities, gigantic opportunities for every one of us. Social entertainment, you know, there are going to be a lot of new platforms, you know, try to find my kids on Facebook. You will not find them on Facebook. You know, they're on Roblox, they're on Minecraft, they're on Fortnite. So all these platforms interesting. It's a new medium. We don't know what the rules are going to be on those platforms, how you monetize those platforms. You know, we know our social media are monetized by, you know, collecting our data and pushing us advertising we don't want. We don't know what the metaverse platforms are going to be like. Fortnite is 100% transactional platform. We try to sell people something that they want. We don't collect their data to resell the data. Hopefully that's the model that wins, but we do not know that. You know, we do not know what are going to be the business models. What's going to be interesting in virtual worlds is people are going to come for an experience, and they're going to probably purchase digital goods, just like you go to Disneyland, you buy a t-shirt. So you're going to have those multi-stakeholder interaction in the metaverse where the guy who created the nice experience that attracts the visitor needs to be paid, but the guys who created the goods that got sold needs to be paid as well, and the platform needs to be paid. So all of that is being discussed, being modeled. We do not know what's going to happen there. But one thing we know that creatively is that those platforms have a huge potential for immersive storytelling. You know, we are used to linear storytelling. We've seen a few games like The Last of Us explore immersive storytelling. We've seen Circus, like we have Cirque du Soleil in Montreal. You know, there's a lot of new entertainment forms that can be created there. So we're looking forward to see that. User-generated content is a very important trend. And the other thing is the metaverse is not something that just lives in the ether. You know, with LED screens everywhere and transparent screens, we'll bring that digital content into our lives. It'll come to our phones, that's for sure. But it also comes maybe to our windows, to our windshields. You know, every glass panels in our lives, you know, including our glasses, could become a place when we consume interactive content and leading to a augmentation of our lives. And I think that's, you know, we're already seeing, like, if you're familiar with the Star Wars hotel, the Galactic Cruise is basically a 3-day, 2-night experience where you enter the hotel, you check in, and you are on board a Galactic cruiser, and things happen. And there's all the windows in that hotel are screens. So you can wake up, you know, you can fall asleep on a planet, wake up on another planet. So it's really, you know, it's like theater. I mean, it's really the big creative fusion where the metaverse and this digital content blended in the physical world, we can create amazing experiences. We can create real life Harry Potter-like experiences. So we ain't seen nothing yet, right? We know games and movies, but those guys don't talk. That's one thing we're trying to do at Epic. Say, hey guys, you should talk, because guess what? You know, the people on the French television, they use Unreal. The people doing the events, they use Unreal. The people doing movies, they use Unreal. The people doing games, they use Unreal. Why don't you guys talk? And when we give them 3D platform, I believe they'll create things that we haven't seen yet. So again, if you're an artist you know, if there's an artistic aspect to your mind, there's a lot of interesting stuff. I'm not going to go too much into the enterprise opportunity with digital twins, but as you know, those virtual worlds are used to teach robots and machines about the real world. Whether, you know, we train autonomous vehicles, we train robots in factories, we also train humans. You know, 3D is actually a really efficient form of medium for training, immersive or not. And collaboration through the use of Unreal in the automotive industry has exploded through the pandemic because people were doing collaborative design reviews because they were not in the office anymore. And so there's a lot that 3D can bring there. Avatars is a huge topic because avatars is tied to identity, which is a huge topic in the metaverse. And it's also tied to self-expression. And when you look at Zuckerberg presentation 2 weeks ago, the only thing he dubbed a store was the avatar store, because there is an expectation that our self-expression in the metaverse is going to be $1 trillion opportunity. We'll buy a lot of stuff for our various online personas. And so that's a topic that's, needs to be researched, needs to be worked on. It's one of the first topics that the Metaverse Standard Forum is covering. So it's something where we need, as regulators, as citizens, and as entrepreneurs, we need to think a lot about. But by the way, with MetaHumans, we give you, very compact representation of very plausible humans. So the authoring component is I'm not too worried about, but it's the rest. Digital goods. I mentioned Sketchfab, 10 million users, 5 million objects. We've started to see integrated marketplace. There will be a big commerce around 3D content and a creator economy. What we care about at Epic is we think that, the current store model where the gatekeeper takes 30% off the top, which is basically all the profit, is not something that's just, that should be sustained. And we run all of our marketplaces with a 12% fee, which we believe is an accurate, which gives enough profitability to the platform and is probably an accurate representation of the cost. So lots of things there to reinvent commerce. Branded experience, I want to talk about it because of advertising. I think, the migration to 3D platform is the opportunity to reset some of the things that we may not like. That becomes an opinion. Let's put it something I don't like in the, for the past 15 years of the platform, the walled gardens, the fact that, the data collection that we do not understand, the fact that we get pushed advertising when we don't want it. Think about advertising in the metaverse. I mean, what is it going to be like? In the web, it's easy. It's relatively easy because they have their own squares. Okay, it's certain website is hard to part the editorial from the advertising. Well, we still can't. Okay, we have to squint a bit, But in the metaverse, what is it going to be like? I mean, it's going to be immersive 3D worlds. If you see something, I already see TV shows where all the cars are BMWs. This is not the real world. Somebody's been messing with the world and trying to sell me something. So we do not understand advertising in the metaverse just yet, and we're very hopeful that as we build those platforms, we build them, in a different way from a privacy and data collection strategy perspective. And I think the governments, especially here in Europe, have been leading the charge with GPDR, and we believe we're also pitching advertiser to do something different. Like, we launched Ferraris in Fortnite because it's the engagement with the brand. It's not just in pushing, a piece of advertising when you don't want it. It's about letting people having fun with the products. So we do believe that there are potentially a new world of advertising, but, there are companies making tens of billions of dollars of advertising revenue. They won't let it go. So the battle is on for the advertising model in the metaverse, and it's a complex problem as well. I have a slide on education because if one thing we should do is get our kids, improve the way we teach our kids. The economics of the education market is very complex, but as I said, I'm an optimist. I'm hopeful that we can bring the metaverse to our kids so that they learn faster and better. So again, think about it. So many opportunities, so many arenas that every one of us should look at this as an opportunity and leave the skepticism at the door. Now, open standards. This will only work if we are very sincere about open standards. And I think this is the confluence of two things. One is, as I said, the learnings of 15 years of walled gardens and mobile platforms, where there is only one browser on that device. That's as much as me. I would say, because we are amongst ourselves here, the gap between native and web is surprisingly big on the same hardware. Look at the experience that you can do on a web browser versus what you can do natively. I believe some of it is due to the architecture of the web APIs, to security concerns. But I also believe that a lot of it is due to platform policies when they'd rather vector people to an app store when they do takes 30% than having experience happen on the web. So I think, our future is like the past, is the return to the good old web. And that's why I think, just like the current generation of the internet was built on web browsers and the HTML standards, I think we need to relearn the lessons of that time and create, like we did, with hypertext and text and pictures, recreate solutions to enable browsing. So at SIGGRAPH 2021, Patrick Cozzi and I, we did the first Open Metaverse course. At SIGGRAPH 2022, we did a full day course with this cast of characters, really trying to, further the conversation and figure out how you reconcile the high production value that we see, because that we see in games and movies, because that's the content that people want. Reconcile that with, creating the web of tomorrow. So, and I'm also, it's a shameless plug for my podcast called Building the Open Metaverse. We interviewed Buzz last week. We have Pink Fu this week. She's an amazing entrepreneur. You should listen to her story. She created Geomagic. She created, she's working on Burning Man, Live Nation. So it's very, very interesting woman. So, but when we talked about all of those people on the podcast as a continuation of the SIGGRAPH activities, we realized that people were not talking to each other. And that's what, with Neil Trevet, who's going to be talking, I think today or yesterday was talking here at the conference, and with Patrick, we realized that there was a need to talk and synchronize roadmaps. There was no venue, like the open source people are going left, the open standard people are going right, or multiple rights and then multiple lefts. And ultimately, we want to have interoperability for fully simulated worlds. It's a lot of things to standardize. And so, but we said we need to start now. It's not about to quote Neil Trevet, we're not at building cathedral now, but we should bake the bricks in a way that, we can all build our cathedrals together. So we created a Metaverse Standard Forum. You know about it. It's a forum. It's not a standard defining organization. It's just a place to host a conversation between, the people doing the work in the industry, the people doing the standards, and the research institute. We started with a few people, which was already good. In June, but then we got flabbergasted because we have 2,000 people in the forum now, which is a curse and a blessing. It's a blessing because it tells us that, open matters to people. It's a curse because I don't know how we make things happen. I see Mikołaj shake his head. I don't know how we make things happen when you have 2,000 people, 2,000 voice around the table. I don't know how you make things happen when, a two-person startup has an equal voice to, than an industry juggernaut. Well, we have some ideas, and that's the problem we're trying to solve right now, is to get the conversation forward in a way that is fair, open, transparent, but yet action-oriented. I told Neil and the guys, I'm like, if we do this, it's going to be about action, not conversation. Nobody needs another forum to converse on, the beauty of open standards. We need to get shit done, and that's what we're trying to do. People ask, why did you do that? Because we were looking at divergence, right? You had the movie people doing USD, all sort of problems, and you have other people like GLTS, they were trying to venture outside of objects into scenes. The way they planned to do that was completely incompatible with USD. And so we said that cannot work. And so one of the projects we created is, try to work on 3D asset interoperability. That's the tip of the iceberg, by the way, because fully simulated world, a lot of data types, video, audio, there's going to be a lot. There is 10 years worth of work to be done, guaranteed. But at least I'm going to say, if we want to be credible and serious, we have to work on 3D. We have to take something that I describe in my mind as a mildly interactive experience. It's not Call of Duty, okay? It's like, think about a car configurator or a virtual selling experience. Let's make sure that we can author in one package, modify another package, and share it into multiple platforms like Roblox, Fortnite, and or web-based platform. But then when you start to think what it means, it's like, should they look the same in all platforms? No, I mean, when think of Fortnite, Roblox as a visual signature, so how do you standardize those things? So that's the conversation we want to have, because when you start to unpeel the onion, there's a lot of complexities. And so we have started a working group on 3D asset interoperability. We have, I think we have a lot of people around the table, but we have the leading 3D companies that you saw the logos on previous slide. That's represented last week there. I think where we are right now is more about agreeing on the principles, than we are actually busy writing specification, and this is how things would be done. So the first conversation is that we're having will be to define the charter of the group, which is for me agreeing on the principles of what we want to be doing, and you can read some of that. Being minimally prescriptive, but yet I don't think we should wait and divergence. So we really want to hone on the absolute minimum that needs to be defined, because we know. We're at the beginning, we know nothing about what the 3D is going to become and the metaverse is going to become. We may have ideas, but we don't know what's going to happen. But, similarly to HTML, like this ability to compose scenes from 3D objects coming from multiple sources. So scene composition, scene layering, I think that's what we should be starting with. And I think we're very lucky that there is a model that seems to work across multiple industries that has been, the model that has been implemented in USD. I think we have something that stares us in the face that is proven to work for linear interactive content. So it should not be discarded. So, but again, the approach is to, not to insult the future, let people innovate and be absolutely minimally prescriptive with the goal of sharing experiences across platforms. And that's essential if you want to create a fair economy. If you want people to create content, they're not gonna, if they have to create different content for Fortnite and Roblox, big fail. Okay, and we're gonna preaching that, we look at the Unreal Engine, the tool to create content for all platforms, not just for Fortnite or the Unreal Engine based platform. Through the support of standards, we want to use Unreal to create content for anything, including for Unity or Roblox or any of those platforms. And then there is a few things that, remember in 21st century, so everything we do needs to be multi-tool and multi-user, because we know that people like to mix and match a lot of tools from Adobe or Autodesk and all those people. And fundamentally, again, it's 21st century. We want to be, we want to dog food the good side of the metaverse through multi-user collaboration, and then also acknowledge that an experience is something it goes way beyond 3D assets, as I said, audio, spatial audio, video. There will be an infinite amount of screens in the metaverse. The metaverse will drive consumption of video streams. So video needs to be a first-class citizen in any metaverse platform, in my opinion. And so that's what we're going to be trying to do. Wish us luck. We're starting to work with kind of 110 people in that work group. It's better than 2,000, but it's still a lot of people. And so we are honing our governance model, and we're trying to be, again, pragmatic, action-oriented, and get the big guys in the industry to commit to those things so that it shows up in the tools. Because the standard that doesn't get used is a very mild usage for everybody, which is, something. So if Web3 is about blockchain, I don't want to talk about Web3, so I'm going to invent Web4. Maybe it's already invented, but I think we are at the moment when we need to think about, how we're going to structure, the internet, the virtual world, the metaverse, and I think it's for me, it's Web4 is like, if it's called Web4, it's like a bit of a return to Web1, but in 3D. We have to think long and hard about what we've learned about open versus closed. We went from Mac Windows to iOS, Android. There was not a progress in my mind. We have to bridge the gap between browser-based experience and native. I think it's critical. I'm a firm believer that the current state of browsers is more, as I said, more a reflection of policies than is a reflection of technology. The adoption of a web GPU, WebAssembly, WebNN now, all that stuff needs to be, we need to throw collectively our weight behind those things. And I do believe we can create a next generation of browsers to implement that. And I think, we will be successful, and, the metaverse can have an even bigger impact because it impacts our social interaction than the internet had. And therefore it needs to be, it needs to be open because it'll play a big role in our lives. So as I said, regulators, citizens, and the academic community and the business community need to come together and think long and hard at the online world that we want to create. We're not going to make it with Roblox.exe and Fortnite.exe. It's not going to work. We know that. I mean, we are CompuServe and AOL. We haven't created the open internet, and we have a few years ahead of us to get that done. And that's why I was super happy to be with you today and talk to this community, because we care a lot about that. Thank you very much. Right on time.
Yeah, but right in time to finish the speech. But I would like to take some extra time for some questions.
Sure.
Because you had so many things. I prepared my eggs, but yeah, let's hear some questions.
Hi, Marc. Thanks for the presentation. I'd like to do a correction and one observation. The correction is that your first test in 3D was right in this school, a project about Z buffering with Mikołaj, if you remember, and then Deus Ex Machina for Mikołaj. So this was for the correction. And the observation makes that, yes, it's 34 years now that I'm interested in 3D. And what I've listened to in your talk remind me a lot about what the first VR project was about back in the 90s. And considering assets as being not only geometry, but geometry plus behavior, and having to be inserted into a common thread of functionalities to kind of mimic a shared reality. Want to come back to what Mikołaj said yesterday morning about killer applications in VRML that were remaining in silos, because I think reality is shared among reality is an experience. So anybody has his own reality experience of reality. So I'm personally training firefighters most of the time, and they have their own reality and they're working in a silo, and I got 3D applications that are working very well in my silo. When we want to talk metaverse, we want to talk about shared reality, so that everybody can experience a reality. So it means it's got to be based on expected behaviors, got to be based on expected functionalities and expected reality. I mean, because, and what I heard here is very much like what I heard about virtual reality back in the 90s, but only focused on 3D and capabilities. So
it's just happening at a different scale. You know, what was the exclusivity of a happy few with gigantic budgets is becoming available to many more people. And you know, for the creatives, photorealism is an unbearable constraint. I mean, you know, photorealism or realism is not a goal. We do expect, like, you know, look at Avatar, the world of Avatar. I mean, it's very interesting because we understand what things look like, even though navis, like, you know, people of 2.5 meters high with blue skins do not exist. They still borrow everything from photorealism to create this world of fantasy. And I think that's, for me, something that is important, why photorealism is important for a platform, because that's the base tool. It's going to be the brush you give the painters to create their world of fantasies. But I do expect, that's why when you think about interoperability, it's becoming very complex, because you have to, that's what I was trying to say, you have to leave room for interpretation. You know, the way something will look like in Fortnite, you may choose to have a visual style that's nothing to do with photorealism. And so, you know, when you have to think about so many of those dimensions, that's why the minimally prescriptive approach is fundamental, so that we think long and hard about the absolute minimum that needs to be defined.
I started building tools to train wildfire fighters, forest fires fighters, and back in the late 90s, so we needed many computers to get VR shared for 6 or 7 users, and amongst those users there were pilots. And the 3D at the time on the 90s was kind of chunky, but still we had the pilots just going to see under the nose of their plane on the screen. Okay, so they were engaged, and the people on the ground, some were going down to fighting each other if things were sometimes going rough. A lot of testosterone sometimes in firefighters, and the realism wasn't the key, but the reality was here. They were in.
Yep. Thank you.
Not really a question, but I'd like to invite you to the workshop that we're doing tomorrow afternoon on virtual clothing to physical clothing and the gaps and the things that we need to work on. So if you're around tomorrow afternoon, that'd be awesome, and we can go into detail.
I will not, but I want to know about it. Actually, yesterday I had a meeting with haute couture house called Julien Fournier. And, you know, haute couture, the pinnacle of handmade work and everything. But they do want to use technical tools, but it's just not up to snuff, you know. The look is okay, but Mousseline and organza do not behave the right. You know, if you look at the video games, like everybody's wearing a scuba diving suit now. You know, it's like another skin. It's not clothing yet.
Okay, Leah.
Hello, and thank you for your presentation. I'm very excited about the metaverse and especially how we will interact with it. According to you, is already a part of it. How we interact now and how we will interact in like 10, 15, 20 years? Will we go full haptic suit? Will we go brain computer, Elon Musk style? What do you think?
Well, I'm looking at, I prefer LED screens to VR headset. I speak my mind about core. I will go in a headset for core presence, but a super high quality interaction. But for the rest, there's so many things in my life that could be augmented with content on my screens, on my windows and everything. So I much prefer to think of it as an augmentation of my daily life than think of it as, something that I have to isolate myself to enjoy. I will do that to get core presence, guaranteed, but otherwise, I want to be in the real world. And I don't, so, it's hard for me, and maybe it tells you that I'm an old fart, right? But it's hard for me to imagine a world where haptic suits, it means nothing to me.
Anita?
Thank you for a great speech here. Avatars will be a big part of the metaverse. Have you guys thought about standardizing avatar or maybe having some best practices? Every game engine has its own avatar specification. How do we go from one world to another if we have different avatars here?
So you will not be surprised to hear that when we polled the companies in the Metaverse Standard Forum, what do you want to talk about? 3D asset was number 1, but number 2 was avatars and identity. And number 3 was privacy and safety. And so the topic of avatar, I touched on it because I think it's particularly complex because, it's likely to be one of the vector of monetization. And so, like today, that's what we do in Fortnite. I mean, we sell skins. Not looking forward for kids to upload their own skins in Fortnite because they would kill the business model. And we're not, we're not a nonprofit. We're running a business on that. So it's, I think that this business model constraint, and I call out that, the only thing that was called a store in the meta presentation was the avatar store. So that's why I believe they are going to be more constrained than anything. Now, yeah, on the paper, it would be great to have standardization. I think when you look at the work of Meta on Codec Avatar, the work of Epic on MetaHuman, or the work of the Ziva team at Unity, you started to see some common threads. We all use the same fax system for face, the 132 shapes. So we all use the Apple standards for, the lowercase characters, the emoji structured. So I think for authoring and playback, there will be, I'm confident we'll arrive to solutions. But then I don't know that the platform rules around the avatars are likely to be complex. That's my expectation.
Jorge?
Thank you, Marius. So I'm Jorge Posada from Bicomtech Research Center in Spain. It was a great talk. Thank you very much.
Thank you.
I'm very much interested about your thoughts in how the metaverse will affect economic sectors. So what I mean is the following. One thing is the individual, and of course the entertainment sector is a very clear case, but is it going to affect, according to your opinion, to more, let's say, professional sectors, I don't know, health, industry, other?
I think, so just like, digital technology has been a massive productivity boost. I think you'll see that, traditional industries, so digital twin, already helping in the automotive industry, support collaboration, more efficient support simulations. There's so much software in modern manufacturing. You can train, you can train your software models. So there's a massive boost, like there's a surgeon, that was starting to use AR for surgery. And he said, for me, it's like the progress is the same, like, driving a car with a paper map versus driving a car with a GPS that tells you turn left or turn right. So I do believe that, there will be enormous value in all sectors, actually, with the use of real-time graphics. So I'm pretty convinced of that. The other thing that makes me optimistic is this creator economy. We are likely, because it's already happening every day, you have 600 million people on those 3D platforms actually partaking in buying or selling things. So that digital economy that is, been portrayed by Zuckerberg to be a multi-trillion-dollar economy, I do believe it will happen. And I think for our kids, they're going to have access to jobs that we could not even think of, and that's good. That's why we need, that's going to be my meeting this afternoon, so I cannot say this afternoon, I'm meeting with the French Banque Publique d'Investissement and all of those institutions to try to motivate them to add real-time 3D to the courses as early as possible, because that will, in my opinion, become a core skill for us, for our kids. Remember, the government move at such speed that you have to project 5 years down the line. And I think in 5 years, you'll have so much, need for that digital content. And you'll have so many better tools with AI that, you can actually think about creating a lot of digital content, and it will be an integral part of the economy. So that creator economy is important. We want it to be fair. That's also a thing. We want the creator to make the money, because what we've learned in the current platform is the creators don't make the money. The platform makes the money. So I'm not going to mention our very public fight about that, but when we say creator economy, we want the creators to pocket the cash at the end of the day.
Okay, just a last comment or maybe question. When I see your slide with the logos that became from what, 40 to 2000, it looked for me like I had the feeling of Bubble Tower, which we know that didn't end happily. And the other feeling I had is that this is an initiative which is North American driven, is not a critics, but humanity is much larger than that. And I think it's also the time to look much broader than only that big actors, of course, but still they represent only 0. something from the world population.
It's hard to disagree with both comments. People call us crazy to try to do that now, and we're like, well, but at least we need to try because it's important. And even if we fail, we'll have learned something. We don't have any intention to fail, by the way, but even if we do, I think we'll have moved the conversation forward. Now, I'm a repentant French because I've been 25 years in North America, but I do agree with you that you will hear me always talking about the regulator, but to be honest, I don't think the regulation will initiate in the United States, and I think Europe has a very important card to play in being a leader, in establishing new platform rules, in establishing new privacy rules. I mentioned GDPR. We have specific regulations for kids, but I don't understand why I don't get to be treated like kids, and have the same level of respect of my privacy that we expect from a kid. So, I do believe that Europe has a tradition of subsidizing creative industry and culture, which is not happening. Hollywood is, the US are run by Hollywood spreadsheets. So I think through that disruption and transition, Europe has a big change. The European community has an opportunity to really lead in regulation, lead in platform, lead in, I mentioned immersive storytelling. We have Circus in Montreal, but that's what I'm going to talk to the BPI this afternoon. Is like, let's get those guys together. Come on, they use the same tool. They're going to use the same platforms. Let them fuse, games and movies for real, and ballet and opera and theater and all those art forms. It's like, TV did not kill the radio. The metaverse will be a very, very prevalent form of entertainment. There will still be movies, but we need to create something that matches the capabilities of the medium. So I think Europe can play a big role there. There's so many European programs like the Cartoon program and all those things. So yeah, it's a chance. Now, other part of the world, they want their own internet. That's a completely other debate when you think about China and even Russia to some extent. I think they are in a very different dynamic. One thing I discovered this trip to Paris is this notion of French or European sovereign cloud. So interesting time to, the regulator. So we have to be careful who you elect, because they have a lot of important decisions to make.
Yeah. Yesterday evening, we decided to let them die, the old guys, and just wait for the new generation. But that was Michael Zida provocation. Okay, good. Thank you very much, Marc. It was a pleasure to have you.
Yeah, it was a pleasure to be here.
Thank you. Thank you all for the questions.
Merci.
So,
Hello, can you hear me? Unfortunately, I cannot hear you.
Check. Can you hear us online? Yeah.
Yes, I can hear you.
Thank you, guys. And now we'll see if this one works. Can you hear us? Check. That's a Roger.
Yes.
Okay. Okay, very good. So give us another minute here. We're trying to straighten out the connection for our first presenter. Mikołaj, have you requested a screen share?
Yes, but I was unfortunately I'm not Mikołaj. He couldn't attend the meeting today, so I'm another author. So I will be a substitution for him. I hope it's okay.
Speak again, Mikołaj.
Unfortunately, he cannot attend the meeting today, so I am the substitution. The substitution. I am another author of this paper.
Check. I see some activity on his side, but no. There comes something. Wonderful. I see a control has come through. Okay, we've got the presentation. Now we're going to try to make sure we get the audio. Can you try to speak, please?
Yes. I'm speaking now. Can you hear me? I am speaking.
Signal.
I am speaking. I am speaking. I am speaking. Can you hear me?
You have it on the phone, the audio from this side, yes?
Yes,
You hear
speaking.
it from the.
No. No, I didn't hear that. So.
I am still speaking. On chat, I can see that.
Okay, we're trying to get the audio in the house
Okay.
to connect. So just a moment while we work out the technical difficulties. For the speakers in this session, I would have to apologize and ask that we can maybe compact our presentations to 20 minutes each instead of 30. This way we can make our timing targets. Stuff not there. Let's see. Can we get someone online to give us a hey, hey, shout it out? Anyone? Trying to get some, okay. That's, they can hear us, however, we still can't hear Mikołaj.
Can you hear me? Can you hear me now? I am speaking. I am speaking. Can you hear me?
Okay, so you can hear him, but we can't. Okay, interesting. Okay, so the online folks are able to hear Mikołaj's audio, but we are not. Okay, great. Thank you guys for keeping us posted. I'm gonna try to iron this out locally.
Can you hear me?
Yes, I can.
Okay, so online, can you hear me? Can anyone in the room hear me?
Yes, I can hear you.
Okay,
I
must be
see.
just an online
Okay.
thing.
Well, all right, folks, sorry about that. I apologize. What we're going to do while we figure this issue out is we're going to invite our in-person presenters to give their presentation here locally. And meanwhile, we will try to maybe restart a laptop or something and get things reset there. So we have a first paper for in-person here, which is the evaluation of simplified 3D CAD data for conveying industrial assembly instructions via augmented reality. And let's see, we have Abhaya Dhathri. Okay, wonderful. So let's welcome her, and you will be sharing from your teams. Okay, great. So I can pull this.
Thank you, Mike. Yeah. That was screen. Screenshot. Or the other. Let's see what's going on. It's not shared yet. You're just it's going. Yeah, no, it shows. Okay.
Hello everyone, my name is Abhaya Dhathri Arige. I'm a PhD candidate France, and today I'm here to present my paper, which is evaluation of simplified 3D data for conveying assembly instructions via augmented reality. By coming to the presentation, I started by introducing the context of both AR and assembly lines retrieval, which is followed by the experiment setup, because our paper mainly focuses on the subjective evaluations. and then the evaluation potential, how the evaluations are performed, how they are carried out, who are the participants that were involved, what are the tasks done by them, and also how we have calibrated the evaluation metrics. At the end, I will summarize by concluding the contributions and the findings from our works. So here's an example of the classical assembly line setting. So when you are in an industry and there is an assembly line, there is a big workbench which is divided into different workstations. So at each workstation, we have different types of components which are arranged into bins or containers. So when we start the assembly, the semi-assembled products move from one workstation to other workstation until we reach the last workstation. Then we have a finalized product. So depending on the complexity of the task at each workstation, we have one or more operators working at each workstation. So right now what we have is a manual instructions for the operators. So whatever assembly they have to do, they see it in a piece of paper, how the assembly has to be done or what they have to do at their workstation, and they follow the manual instructions written on the paper. But as a part of Industry 4.0, AR systems are now used as training platforms for assembly line operators. So what happens when we use AR instead of manual instructions is the number of errors that the operators commit during the assembly becomes very less. And after the training becomes very faster. When the training becomes faster, the productivity of the industry increases as well. And also it ensures the versatility of the operators because once an operator becomes familiar with the headset, he could go to any workstation in the industry, pick up the AR headset and start working right away. So the flexibility increases, which ensures the versatility. Also, AR is very close to the real world environment, so it ensures a more natural learning process. So when it comes to the types of instructions in AR, we have two sets of instructions. One is image, audio, video, and text, and the other set is 3D and 3D animations. In the first set of instructions, the creation process is quite straightforward and quite easy. But the problem with that instructions is they occur with the real environment. When it comes to the next set of instructions, it's 3D based instructions. 3D based instructions have a very realistic augmentation, but the problem with 3D based instructions is they are not quite straightforward. The creation process or the pre-processing or the preparing of the 3D models is not straightforward. So why we say this creation of 3D models and the pre-processing is not straightforward? Because we cannot take an original 3D CAD model and directly put it in the AR device like HoloLens. Because these 3D CAD models are created for industrial purposes, not for just visualization purposes. So they have a lot of metadata associated with them, a lot of details, a lot of functional properties. So what we propose is take the original CAD model, simplify the model, and then put it into an AR device like HoloLens. So this is where our work is mainly concentrated, simplifying 3D CAD data for AR systems. So the same thing is here depicted with the help of a small example. So these are the 10 models which needed to be assembled at a particular workstation. So when we tried to put them into our AR headset, the frame rate was about 16.9 FPS. But for the device like HoloLens, the frame rate, the optimal frame rate is around 30 to 60 FPS. So rendering them or loading them or creating instructions with them is almost an impossible task. But what we have done is take out these simplified models of the original models and put them in AR headset where the frame rate has improved to 57 FPS, which is the optimal range of HoloLens frame rate. So mathematically and technically speaking, this works. So simplifying 3D data and using it instead of the original models, this works perfectly fine. But at the end of the day, what's more important is the quality of experience and the user experience. So we use simplified models now. What if the operator doesn't understand the simplified model? What if he cannot identify the original counterpart with the help of simplified model? What if the simplified model is creating a confusion or latency in the instructions he is doing? So this has to be evaluated subjectively. So in our work, what we do is use the evaluations and calculate some metrics based on these evaluations to see if the simplified models are real or if can be really used in AI systems. So before going to the experiment setup, we are saying that okay, we have original models and we need to simplify them. But what are the techniques we have to simplify these models? So when we talk about carbon simplification in literature, we always use representation called mesh-based representation. So when we talk about the simplification techniques of mesh-based representation, we have 4 types of simplifications. One is vertex removal, the next is edge removal, triangle removal, or vertex clustering. So we either remove a vertex, we either remove a vertex, edge, triangle, and reformulate the whole image, or we do a 3 vertices in the single vertex. Likewise, we simplify the image. These are the basic techniques that are available in literature. So we have done an extensive research on the available techniques and we did 5 algorithms, at least from each techniques we have discussed earlier. So with the help of cross-drop distance, we have calculated a numerical error between the original model and simplified models. For this, we have a database of 730 candidates and all the candidates used for evaluations from an industry specializes in assembly of boilers. So these are not any other CAD models that are available on the internet or the local grids. So we have ensured that we have used original models. So what we have done is we have taken all the original CAD models, simplified them at different simplification ranges. 50% in simplification, 60, 70, 80, 90. So at all percentages of simplifications, we have calculated the cross-drop distance, which returns a numerical error between the original and simplified models. So at all ranges of simplification for all the CAD models, we have seen that Lindstrom et al. In literature, which was implemented in the SIGA library, has outperformed the rest of the methods. So we have retained this simplification technique to simplify our methodologies for AI systems. So when coming to the experiment setup itself, in the experiment, we have 3 types of tasks. One is simpler, medium, and complex. So in simpler tasks, you just need to take a 3D model or a virtual model and place it. So it has nothing to do with any complexity. It's very quite straightforward. In the medium task, there is placement with some alignment. In complex tasks, there is placement, alignment, and orientation. We have taken different range of tasks to perform the evaluations. Also, the actions involved are do, fix, install, place, push, and slide. All these actions are the most common basic actions that are used in assembly industrial line. So when coming to the CAD models, we have also used the most used CAD models in an industrial assembly line.
We don't need this now, but.
So coming to the tasks, as we discussed, we have 3 levels of difficulties. And for suppose in simple level of difficulty, we have 2 CAD models. We have created the instructions with their original and their simplified counterparts. After all the evaluations, we have calculated mainly three metrics, which is the difference times, senders, the number of days during each instruction, and the comprehensiveness of the model. So when coming to the level of tasks, as we seen earlier, in simpler level of difficulty, we have two tasks. So what happens is, when a participant one comes in, he sees the instruction with original model of one task and simplified model of another task. This is because if there is original model and simplified model of the same task, if the person is doing the same task, if he is duplicating the task, definitely the ones he is doing the second time, the metrics will be definitely biased and they will be definitely better than the previous one. So in order to avoid this, we have taken two similar tasks and we have shown with one original model and one simplified model. When it goes to the next level of difficulty, it is quite opposite. Now we take a simplified model first and an original model next. It's quite opposite to the next one also. This is what the first participant does. But when it comes to the second participant, he does the quite opposite of what the first participant has done, which is he sees the simplified model and then the original model, and then the opposite of both. This is all done to avoid a bias of having both original and simplified models at the same time. So what we have done basically is we have divided the whole task into two sets in which the participants will do. The first participant will do one set, the second participant will do another set, the next one will do like that. But at the end of the day, when we calculate the metrics, which we measure how good the simplified models are, we don't compare in between the participants. We only compare in between the original In order to conclude my presentation, I would like to say the main contributions of the paper are we have analyzed and explained extensive approaches in the literature to see which simplification technique is suitable to simplify CAD models to be used in AI systems. Our second contribution is in objective evaluations to see if the simplified CAD model can be used inside AI systems. When it comes to the findings, we have found that with the help of few user evaluations, that we had no noticeable differences or no effect on the performance or the quality of experience when we use simplified models in the place of original models in AI systems. So for future work, there is one thing we could do because now, this is when the 3D models are simplified, we select manually which range of simplification to take. Like if they have to take 50% simplification, 60% simplification, we have selected it manually. But one thing that could bring more value to the work is to select automatically the percentage of simplification so that the simplified model remains close to the original model. That's it for our presentation. Thank you for your attention.
Hey, thank you so much. We have a little time for a question while we continue to work on our technical issues. Are there anybody have a question, or we can move along? We have one in the back. Okay, thank you.
To mute.
Yeah. Okay. I will do this while the technical issues happening.
Yes.
Sure. Okay.
That is laptop there. That is laptop.
I was just wondering if you're going to expand to tasks like sewing or assembly. It's a little different than just the screwdriver or something with soft materials.
No,
the question was about other sorts of materials that might be on the assembly line or work. Sewing, for example, or other kinds of manufacturing, maybe clothing, possible.
Absolutely, but yeah, inside industrial assembly lines, when you consider especially industrial applications, we only have CAD models like this tools, pins, ingredients, or points. These are physical objects which are very heavy in nature, but yeah, it could be extended to any other industry, in any other course. It's just once we have the 3D model of whatever industry you are in, it can be clothing or anything. We can prepare a simplified model of the same and put it in a headset and start training. It could be extended to any other industry.
Great, thank you. Thank you, great. So now we will invite the next paper who is local and on site. Thank you. We have the next paper in the session, Database for Camera-Based Document Image Retrieval. Thibault Lelong, I believe, is going to present it, so I'd like to welcome him up now. Thank you. And I will ask our online presenters to keep attention on the chat, and we'll be trying to coordinate with you about the permissions for sharing, and just to make sure that we have the signals ready to broadcast. And here on site, it looks like we're coming together. Okay.
Can you hear me? We have to restart my control drive. Okay. That's my yeah. Hello, I'm Thibault Lelong. I'm a PhD student at Telecom. Sorry, I'm also an engineer at Chicago. Startup which provides some tools for creating higher experience. I mean, Augmented or Marcellus explains. So today I'm going to show you a new database for the retrieval of camera-related intelligence. Okay, so first, why is that base? Actually, when someone wants to create a marker-based AI experience on several weaknesses, he has to associate marker with their contents, you see, and all this information will be hosted in server. There are a lot of marker or interaction, and he has to develop a human recognition engine that it will host on server too. Finally, you need to develop your own IR application, native or web. So in this demo, it's the Argo Web AI player that we developed. So in this case, after marker recognition, the application just start to track the marker and display all the content over the marker. So how it's work? Actually, the marker-based application is divided into two steps. The two sides. The first one is on the client side. It's the application which contains an image tracking engine, and before tracking anything, this application must know which marker this. So to do this, this application have to send an image to a server to obtain and identify the right marker, and the server will send back all the information. Actually, the server works in two ways. First one is applied but not applied with Argo. It means that any client can add some document or delete one or update one and update their contents. And the online part is corresponding to when the server receives the image from the application and try to recognize which marker it is. So the server had to identify the document, we send back the information and the information to marker is on. So actually, when the user scan a document, there are possible claims. The first one in this video The document is not localized, so the app is working. It's a false negative case because the document is present. The second video shows the case where the document is well identified and we just the right information. The application starts to contain the marker. The third video shows the most problematic case. It's when the server sends back the patch marker information, and that there is a confusion in the document location in the fourth view. It's that this can neglect the user experience when, for example, in the industrial case, when users scan the catalog and it's a case event, the application will load, for example, bad link or buy something in catalog. So this problem can be explained both on the application side and sub side. Application side is when the resolution of the image is too low. There are some deformation on the content marker or some vision. And on the server side, it's when the database is huge, or what kind of descriptor the document will operation design we use. And the problem is when client wants to open some document were exactly similar. So to work on this problem, we look for a database, and actually there are two databases available for document image retrieval, but none of them allow us to work on this type of industrial problem, I mean problem. So we decide to create a new one. So this database must contain documents that are similar, and these documents can share some textual or visual information. The query image must be as close as possible to map from industrial application. And obviously, the database must be as large as possible. For the challenge part, the machine calculated the quality of the system only with the best results, because we don't care if the quality command is in the top 5 region. We just need to top one. And the system obviously must also have the ability to provide the best response if it's not true or there isn't any dead document on query image. Finally, the execution time must be short. So this new database currently contains only 596 documents and 2,780 query images in different resolution. This database is divided into 6 categories of documents. You can see the table. The document can be composed with text, English, French, or random text, or the visual information or both. To read this database, we have retrieved some existing documents from paper or from Argo clients. And we also generate some document with a random template that we found online. In the future, we can generate more document that in order to increase the size, but it's pretty long to record query images on each document. So in 3 categories, we have documents which look similar: business card, invoices, and posters, templates. For invoices and business card, all the documents use the same templates, but in the case of poster templates, there are 6 subcategories. For each subcategory, the types and price of the area are not the same. We have to increase the number of documents, obviously, and record the query images. You can see the different template on this subcategory, this side. The green area corresponds to each document. The position where similar areas are located identify the right document in each groups. So the first evaluation have been done on Visual solution, provide a company which provide some tools to create IM application like markerless or marker-based or object tracking. And they are also propose the closed regulation engine. So we don't know exactly how the engine work, but and which feature they use, or if there is any processing algorithm in front of their own visual search engine. But it's a good start to evaluate our database. So I upload all my database, and I only use one image created by document for each evaluation because I have to pay more for more images. The review provided by the HRI retrieval in terms of recall metrics, in that their engine is able to provide low resolution images that is fine. But in case of the document which look as similar, the precision device, so that's the point where we have to work and provide a new solution. So we also implement a test bed based on local descriptor and global character and visual world. For manage the Canadian research use case, which is a library for efficiency research and released by AI research. For the development part of the short is provided by Space with the report matching between the query image and convey and estimate the number of layers thanks to Walczak, which estimates the demography. So we compute the ratio between layers and matches and set the threshold to accept or not the best result. So we start to evaluate the quality of global descriptor and their ability to provide the right document in the list of candidates. In this graph, it's the top 20 candidates. Currently, the best combination seems to be SIF and glide, achieve almost 50% of success currently. It's not pretty good. So after we evaluate the solution of precision and recall metrics depending on the in-layers of threshold, we can see that in case of threshold at 0, the precision is at the lowest and will increase at the same time as the threshold increase to recall metrics. So such as logic, nearly around 0.6 the threshold, the curve goes to 0 because the threshold is too high and don't let any result to be validated. So if we set threshold at 0.2 for SIF and glide combination, we compare with the Zaharia, I got a better result on recall metrics and also keep a better precision. Obviously, as we saw on the previous slide, if we increase the threshold, we can probably get better precision, but the recall will drop. We also implemented 2 deep approaches for the construction of global descriptor. To train this model on the future model, we select 200 documents on the database, 35% in each categories, and we generate sensitive data with the deformation, occlusion, etc. to be as close as possible as the query images. And our validation dataset was the query images of the 200 documents, and the bulk model that I will present you were trained on 40 reports and one on GCF, so 10 and 80. So we select the first model, is the dog model. The authors propose a deep orthogonal local and global information framework for end-to-end human retrieval. This approach allows to provide a global descriptor without going through the long step. since the in our case, we use ResNet Petit for encoding part. We set the out dimension at 2048, and actually this model uses the arcface loss function for training. We also develop another model, which is classic. We use ResNet still also for angular part, and we have the squeeze and station network and the global average pooling, and the fly frequency layer to provide the descriptor. And the cost function is complete with the two-pet loss and percent probability loss, and the out dimension is like the prediction loss. So then we evaluate, compare the result with the system lab, and trace the different approach with better precision. Especially the last model. But I think that if we need to try to train the dark model with two loss, like the two-pet loss and the percent loss. So to conclude, the future work will necessarily involve the evolution of this database and the addition of a new document. It will be also interesting to add information on the query image, like the position. It will be useful for other subjects like document segmentation and detection. And for the experiment, we will test a larger number of models present in the literature, like So this database is already available on my GitHub, and that's all. Thank you.
Okay, thank you so much, Thibault. Is there any questions on this? For Thibault? So we will, thank you very much again. Lots of great potential, again, when we're talking about mixing the real and physical worlds. We're still having challenges with that, as you can tell. So what I'd like to do is propose that we take a 10-minute break, coffee break, bio break, whatever you need. We're going to set up the audio video so that we can have a nice, clean reception for our online presenters. So please come back in 10 minutes. We will resume the session. Okay, thank you.
1, 2, 1, 2. 1, 2, 3. 1, 2, 3. 1, 2, 1, 2, 1, 2, 3. 1, 2, 3.
Testing audio, 1, 2, 3.
We hear you, 1, 2, 3.
All right, online can hear me. Can in the room hear me?
Is it both speaker clear?
Can you hear me?
I can hear you.
Okay. But one thing, unfortunately, the presenter Mikołaj could not attend the meeting today, unfortunately. So we have prepared
Hello, Don, and the others. Can you hear me? Yes, it looks so. Great.
Yes, we can hear you in the room.
And then we have also to check if we can hear someone from online. So can you activate Mikołaj as a presenter?
Mm-hmm. Like I said before, unfortunately, I am not Mikołaj. He could not attend the meeting today. So we have prepared the video of the presentation.
Okay.
We have sent you to on the Dropbox that
so
was
it looks that people are can speak in Teams, but we cannot hear them.
Okay.
Mikołaj, can you say something?
Yes, I am speaking now.
Oh, great. We can hear you. That is a relief. Okay, let's see if you can share your screen. And if we can see your screen. Oh, even better. We can see your screen. Okay, good. So I let you, Nicolas, start. It looks it works. Great.
Okay, so again, my name is Paweł Sobociński. Unfortunately, my colleague could not attend today's meetings. So instead, we prepared a video with the presentation. I will show you the video, and eventually I'm the other author, and I will answer eventual questions. Is that okay?
Yes, please. Go ahead. Thank you.
Okay.
Hello everyone, my name is Mikołaj Maik and I work at Department of Information Technology for Poznań University of Economics and Business. And I am one of the authors of flexible photorealistic VR training system for electrical operators. And I am here to tell you about the possible solution to the problem that a lot of designers of advanced photorealistic training scenes in VR are facing today. And VR applications are popular in many domains, such as e-commerce, tourism, education, and training. Especially in training, VR offers significant advantages by making the training process more efficient and enjoyable, reducing costs and eliminating risks associated with training in a physical environment. With the use of VR, it becomes possible to digitally recreate real work conditions with high fidelity. And this helps companies to deploy training systems representing some of the work environment cases. And employee training in VR is becoming popular in many industrial sectors, such as production, mining, gas, and energy. However, efficient use of VR in a practical industrial training requires high-quality VR training environments, realistic 3D scenes, and natural interactive scenarios. And because creating such VR environments is complex and time-consuming task, existing VR training systems are usually limited to the use of pre-designed training environments. And these environments don't offer trainers a chance to create new or adjust the existing environments to new requirements. And in the case of industrial training systems specialized for a specific domain, the process of designing new training environments can benefit from the reuse of repeating components present in the virtual training scenes. And at the same time, it keeps a high visual quality of the training environment. So, we propose a flexible method of creating photorealistic VR training scenes with the use of library training content. And designing elements of the training library content is a relatively complex process, but once this library is available, a designer can assemble new training scenes from the elements available in the library. And then training scenarios can be added using an easy-to-use graphical tool. This presented method was designed and used as a part of the project to develop a flexible VR training system for electrical operators. Thus, all elements refer to this application, but the development method and tools can be similarly applied to other fields, for example, medical training or in Industry 4.0 factories. While, of course, the condition is that appropriate library for this content, for this field, was built. And here on this video, you can see how this flexible VR training system looks like. And the presented system, the training and the system is carried out using training scenes and scenarios. A scene template is a generic empty 3D model with a specific predefined base hierarchy of scene elements. Then a full training scene is a spatial composition of 3D models of electric power infrastructure. And such scene is built using components taken from the training content library, which allows designers to freely set their placement, materials, textures, lighting, or weather conditions, and add new interactions. And each training scene contains a visual layer and interaction mechanism permanently encoded in the 3D object, such as opening, closing doors, grabbing, moving objects. And to create full training scene, we used a specially designed editor called Training Scene Creator. And it is an overlay for the Unity with its own interface. And complex scenes can be created using extensible library elements or specific tools implemented in the Training Scene Creator. And training scenes are saved in the Unity format and are transferred and distributed to VR training locations in the form of asset bundles, EA packages providing extensions to the basic project. Each asset bundle, each package means a change of the application version installed on training station. And there is also a special editor called Scene Variant Editor, implemented as a user-friendly application in Unity, to create variants of training scenes. And those variants are saved as a textual configuration files and can be loaded during the training application operation. And creating and uploading a variant of a scene does not require creating a new asset bundle and changing the application version. And those variants contain information about the number and the placement of 3D objects in the scene. So it is not possible to compose new objects or change objects' appearance, but it is possible to add any number of already composed objects from the library. For example, in a scenario, one can change a specific model of a transformer to another one from the library, but cannot change its texture or modify the contents of the, for example, control cabinet, which can be done in the training scene creator. And then the last part is training scenario. Those scenarios are designed using Scenario Editor, a high-level user-friendly desktop application designed to be operated by the training staff. And each training scenario refers to a specific training scene. And training is performed using a fully immersive VR application where a training scene, a full scene variant, and a scenario, those three, are loaded. Now I want to talk about the training content library. The library is divided into 4 linked collections: objects, components, materials, and scripts. And within the library, all objects are assigned to categories. And the training object is an optimized 3D graphical model of an element of energy infrastructure. And training objects can be interactive, and they consist of components. And this part, the component, is a 3D repeatable part of the object. And the use of components, the small components, speeds up the design process and prevents repeating the same work. Similar to the objects, those components can also be interactive. Examples of components are transformer body, the grounding, the isolator, and the heat sink. And each object can also have attachment points created during the 3D modeling stage. And it makes easier to configure objects when putting them together. And those attachment points are empty objects that store information about the component's placement in 3-dimensional space, so the position, orientation, and a scale. And a designer creating a full virtual scene needs only to select the components to be placed in a prepared attachment points. Okay, so now about designing training objects. So the first stage is preparation of a point cloud based on the real objects. So physical elements of training environment infrastructure are scanned into polygon meshes. And those meshes are encoded into STEP format. And then there is a stage 2 called processing 3D models. So importing those STEP models into the CAD environment, dividing 3D models into components, grouping the 3D models, and exporting those 3D models. Then there's a stage 3, correction and optimization of 3D models. So this stage aims at correcting and optimizing 3D models that contain unnecessary and repetitive elements and geometry defects. So creating several levels of details for efficient rendering and exporting 3D models into FBX format. Then the stage 4, creating training objects. So gathering all those 3D models in the scene hierarchy under a common grouping object and naming them. Then interactive objects must be equipped with scripts enabling them to react to users' actions and launch animations. Then there's the stage 5, anonymization of objects. So the objects have to be anonymized. This means that all labels and diagrams that differ between instances must be removed. And then all those objects are added to the training content library, and those objects are represented as a Unity prefabs. And the last stage is optimizing training objects. So photorealistic VR training scenes in real industrial applications can be very complex. to enable their smooth presentation on commodity hardware, it is critical to perform actions in improving scene's performance. And the goal was to present each element of the virtual scene in the best possible form using a collection of specific techniques. For example, all subsequent copies of the objects are replaced with prefab. Then creating level of details, so reducing the number of active polygons in the scene by rendering distant objects with less precision. Using billboards, so 2D images of the objects. Disabling rendering of invisible objects and generating objects on GPU. VR training scenes then are assembled from the visual 3D models available in the library using the training scene creator tool. And this training scene creator tool has been implemented as an extension to the Unity editor and provides a set of wizard tools simplifying the creation of specific structures. A designer can use the 3D point cloud from the 3D scanning process as a reference when building the scene. And take a look at this video. Here you can see the whole process of setting up a full scene. Then, when a 3D model of a training scene is put together with the associated databases, the next step is to design training scenarios. And scenarios describe the VR scene behavior and interactivity. And typically the programming of visual scene behavior is a complex and time-consuming process of writing scripts in a programming language. And in the presented training system, it is required that some 3D training scenes are used with multiple different training scenarios. And to design a training scenario, a designer uses a scenario editor, a separate user-friendly application developed in C#. And first, the designer provides general information about the training scenario. Then specifies the flow of the scenario, including the steps, actions, and activities that user may or must perform. And those scenarios are saved on a server in the form of semantic knowledge base. And this knowledge base is encoded using RDF, RDFS, and OWL standards, and includes all information necessary for the proper execution of the scenario. And when, at the end, the training starts, the semantic VR scenario knowledge base is loaded into the application. And each scenario corresponds with a specific variant of a full VR training scene. And the correct assignment of the scene and the scenario is verified during the import. And for the training of electrical operators, we have created a total of 25 virtual training scenes. The training content library was developed in the process of building those scenes. And as a result, the time required to develop each scene decreased. And to check and compare the performance of the created training scenes, we performed a test that measured a number of frames per second. And the test consisted of 5-minute session in each scene, in which the user moved throughout the scene and performed interactions with objects. And during the session, the FPS count was measured and the average of the entire session was calculated. And the results of the experiment clearly indicate that the number of FPS decreased and the size and complexity of the scene increased. However, the results also showed that the training is possible in all scenes without significant inconveniences. In addition, employing newer and more powerful hardware will improve rendering speed and make the simulations smoother. And at last, the method of modeling VR training scenes with the use of library of repeating infrastructure elements enables simplified yet flexible method of modeling the photorealistic VR training scenes. A method of semantic creation of training scenarios enables training staff to build scenarios for the training scene with the use of the database of scene objects instead of forcing the designers to use low-level programming with techniques specific to computer graphics. We also have a few ideas how to develop existing solutions. First, the environment will be extended to support the collaborative creation of scenarios by distributed users. Second, we plan to extend the training application to support not only the training mode, but also the verification mode with the appropriate scoring based on users' performance. And finally, we plan to extend the scenario ontology to enable multi-user training. And that would be all. Thank you for your attention and your time. And I hope that everything is clear now.
Great.
Okay, so if you have any questions, I can answer them if you want.
Okay, wonderful. Thank you, Team Poland and Poznan. It was excellent presentation. I know I have a question or two, and we're going to go into the audience here. I see a hand raised. Okay.
I was just wondering if when you replace transformers and things like that, if you set limits as to which transformers you're not allowed to use. And then also, is there any safety scenarios that you're bringing in? It's high voltage or medium voltage, which means if they do something wrong, they could not survive it. Thanks.
The system do not have any restriction about that because we created a tool for the electricians. So this is for the domain experts. So technically, they should know that they know the best how the architecture, the infrastructure should look like and how it's supposed to work. So no, we did not make any restrictions, but it is a good point that it could be done, yet it was in our hopes to make it for the domain experts. So they have the best knowledge how the infrastructure should look like.
Yeah. So it's a great question, right? Because there's a trade-off. Obviously, if you're training, you're not an expert yet. But there's a, having the 3D models not also being functional in like a network representation, right? So a thing is connected to this thing and certain amount of voltage. Ooh, how about some haptic feedback, anyone, right? Put it on the rumble strip or something. But yeah, so I think there's obviously a way to enrich these kinds of platforms. I wanted to ask, and we'll prepare our next speakers in a moment, if you wouldn't mind to switch displays. The last question for you, for our Poznan team, did you find any relationship or advantage? You mentioned this content library. Certainly in that content library, there are groups of things, classes of entities. I wonder if the semantic information about the models is reflected or stored in the object library, or if that's something that is sort of extra to the model and only loads per a scenario.
So there is no semantic level on the system. Yet when the user creates a scene, then he added the semantic representation, so which, for example, button connects with which element and so on. So it is resolved during creation of the scene.
Okay, thank you for that. I think that's one thing we would like to maybe improve as we've been talking about for the metaverse and just interoperability in general. If we have a property, an object, or a class of properties for an object, that these should be represented with the object. So if I put it into the scene, it's going to behave a certain way in this context or in this context. And that would be an advantage of the semantic modeling plus 3D graphics, and especially making scene creation a little easier. So let's give them a hand again. Thank you.
Thank you.
Okay. So now we have a group. Let's see if we can bring up sharing a screen and an audio from Team Virginia Tech. And we have a presentation about levels of representation in Entomo 3D, and presenting are Alex and Wei. So if you guys can give us a test of your audio to see that you're here.
This is Wen Nie Ng speaking.
Excellent, thank you, Wen Nie. Okay, well, the floor is yours. Go ahead.
Good morning and afternoon. And welcome to the session today on representation level and data infrastructure for 3D models. My name is Wen Nie Ng, Digital Collections Librarian, and I'm presenting today with my colleague Alex Kinnaman, the Digital Preservation Coordinator. Nathan Hall, the Director of Digital Libraries and Preservation, is unable to join us today, but he's been involved in authoring the paper and also leading the project. Nathan's not here, but he's equally important. And we are all from Virginia Tech University Libraries. We have been working on the 3D and 2D digitization of our entomology collection, and one of the many facets is to determine how to represent these objects through metadata in terms of their various ingestions in multiple repositories. Next slide, please. Here's the outline for this session today. We will go through the introduction of the entomology collection, Entomo 3D grant, a quick pipeline overview, level of representation, metadata standards, digital object designs, challenges, and next steps. We included a slide number at the bottom right of the slide for easy reference. Next slide. The Virginia Tech Entomology Collection is the oldest and largest insect collection in Virginia, with more than 500,000 of specimens. It houses valuable specimens such as the American burying beetles that were extinct from the state. The VTEC here stands for Virginia Tech Entomology Collection. It's a synonym for Virginia Tech Insect Collection and currently still used as the collection code. Next slide. The Entomo 3D is a clear funded project in collaboration between Virginia Tech University Libraries and the Virginia Tech Insect Collection to provide online access and digital preservation to 10,000 specimens with high-resolution images, in addition to 3D digitization for 300 specimens from the collections. The 3D models enable close study, examination, and manipulation of the specimen anatomy in a way that we couldn't with physical specimens, especially those that are rare or extinct. This will be the world's largest 3D entomology collection upon completion. Next slide, please. The project goals are as the following: to determine the level of representation as we generate new digital objects for multiple purposes from different data sources, figuring out how to address both the descriptive and technical metadata, finding a sustainable preservation plan for 3D objects, and lastly, provide ongoing access to the entomology collection specimens. Next slide. Throughout the presentation, you will see these partners, the Morphosource, GAN, GBIF, IDIC Bio, repeated many times. They are the external repositories involved with our project workflows, and they will be explained later. Next slide. Next slide, please. The metadata will be represented differently across multiple repositories used. Here's a general overview of the workflow that will provide a better picture of the kind of metadata associated with the process. The collection intake with specimen metadata, and photogrammetry workflow with capturing specimen images, 3D model processing, and depositing 3D models into different repositories. Next slide. Upon getting physical collections from the partner, the specimen metadata, also known as the occurrence data set, will be provided by the partner from SCAN. SCAN is the Symbiota portal site for arthropods network collection. It is also the live data management platform and image repository for our colleagues working with entomology collection. The entomology collection and the occurrence metadata and image metadata CSV file will be packaged and compressed as Darwin Core archive file with an ecological metadata language XML files that describe structural data in the CSV. The package will then be extracted on schedule by the IDIC Bio integrated digitized bio collections and GBIF, the Global Diversity Information Facility repositories. Each of the repositories has built-in infrastructure that enhance data adhering to the digital object architecture data model, such as the data validation, transparency requirements for repository. The harvested data and images from SCAN will be uploaded to our Virginia Tech digital library. Morphosource is used as a repository for our large 3D dataset. Before uploading the 3D model to Morphosource, the data manager will first have to harvest the specimen data from IDIC Bio within Morphosource via API. Next slide. Next, we will briefly walk through the photogrammetry workflow as the technical metadata will be recorded in each of the capture and model processing event. Next slide. The major steps in creating 3D photogrammetry models for the entomology collection specimens, also the kind of metadata that would have to be recorded manually, locally, and on Morphosource. The specimens pinned on a piece of clay and placed on the turntable as shown on the left picture here. The specimen will be photographed at 4 different angles per rotation and turned at a 5-degree interval for each captured image. Each completed model consists of about 364 photographs. Next slide. This table here shows the assets and metadata that are deposited into the morphosource and also showing the workflow, the pipeline. Continue from the 300 images from previous steps. The set of captured raw images will be saved in archival information package and further cropped and saved as TIFF before imported to Edgesoft Metashape to create sparse point cloud and then to dense point cloud. The first heavy mesh and color texture with slight missing details are generated. Next slide. To create a lighter model for web rendering, the mesh generated from Edgesoft is further processed in Autodesk Maya. Missing mesh geometry will also be completed in these steps, and the mesh is also known as the retort model or mesh. Next slide. The retort mesh model is imported to the ZBrush with the initial Edgesoft mesh and color texture for detail restoring. A high-resolution model with lower vertices is generated as the final product. Again, for all the process that just mentioned above is important for us because it will be recorded as part of the technical metadata. Next slide. The metadata. Next slide. The specimen metadata is usually described in Darwin Core, a biodiversity metadata standard with a mix of the widely used Darwin Core metadata. When uploading collection to the origin repository, which is the scan, the repository also generates autobahn fields for associated to the images. We cross-reference the Smithsonian 3D metadata model and use selected elements field for the technical metadata. We also revise our workflow, and technical metadata with morphosource is a continuous effort for revision to best represent our model. Next slide. The selected metadata fields displayed on different interfaces varies based on the anticipated audience at different repositories on what users would want and how they would access the digital assets. Providing just enough for what the user needs would reduce confusion and reducing the carbon footprint as well. For an example, on the Virginia Tech Digital Library platform, we focus on displaying the specimen metadata for general users, of which would be more relevant in the context. Fields display included species identification, identifier, coverage on where and when the specimen is collected, and preservation type of the specimen. We map the Darwin Core elements fields to Darwin Core on the digital library interface. The 3D model metadata is relatively minimal compared to specimen metadata. Only a few of them are selected for display, such as the modality, the rights, and the references that were used to link the records living in different repositories. Next slide. For the research or scientific community who is more inclined in getting 3D dataset for reproducing the models, the derivative files for 2D models and technical metadata can be accessed and downloaded from morphosource, the public 3D web repository for the research community, with processing steps detailed for creation of each derivative file and the partial specimen metadata. The morphosource records will be linked from the Virginia Tech Digital Library. Despite only partial of the specimen and 3D model technical or processing metadata displayed on the digital library and morphosource, the full specimen metadata from scan and manually capture 3D technical metadata will be archived by Virginia Tech Digital Library and available for download in package from Virginia Tech data repository, of which Alex will show us after this. The metadata schema can be accessed from the link in the slide. The Excel file contains full metadata schema with biospecimen and technical data, crosswalk to Virginia Tech Digital Library schema, comparison of biospecimen and multimedia data flow across databases in the SCAN, IDIC-Bio, GBIF, and Morphosource. Next, I will pass to Alex.
All right. Hey, all. I am taking over. I am Alex Kinnaman, the Digital Preservation Coordinator at Virginia Tech. So this diagram shows the three primary pipelines for digital object design: the submission information package, the archival information package, and the Morphosource package, each of which is dependent on its final destination, which we'll be diving into for more detail. So first, the point of access in the libraries is through our digital library. Our digital library is built on AWS and designed with individual serverless microservices that each provide a single service, like fixing, ingest, that sort of thing. The files ingested for strictly access purposes are a lightweight X3D object around 200 to 300 megabytes, and this includes the final mesh, the texture, and the descriptive metadata to keep the bandwidth low and the interactivity as seamless as possible. I will say this access platform is still under development as we prepare to move from our current Sketchfab instance to the digital library, so I can't show you that yet, but it's up and coming. In terms of the ingest process, each object is provided with a persistent non-semantic identifier with an archival resources key, ensuring ongoing access and unique identifiers. Objects are scanned for viruses prior to ingest. The fixity is verified at multiple points via the SHA-3 checksum hashes, and metadata is stored in a NoSQL DynamoDB metadata server and searchable with the rest of our collection in the digital library. Second is ingest into the Virginia Tech Digital Library storage. So our local primary storage is an AWS primary cloud storage in Virginia that is synced to a secondary cloud storage in Oregon. And additional preservation storage is through our subscriptions to either APTrust or MetaArchive. The archival information package contains the crop TIFFs, point cloud, the final mesh, texture, light mesh, and all of the descriptive and technical metadata. And from here, each record is indexed in DPLA and Morphosource, and then linked from their corresponding records in IDIC-Bio and SCAN. And as Wen had mentioned, the source files will be available in the Virginia Tech Data Repository and Morphosource, some of which are live in Morphosource now, so you can check them out. Just a quick note on preservation measures in terms of metadata. Our general preservation metadata is cataloged using the Premise Data Dictionary from the Library of Congress to provide audit logs of initial ingest, transfers, and any other changes made to the digital object. In addition to our local and secondary cloud storage, we subscribe to the Academic Preservation Trust, APTrust, which is also built on AWS with storage in Virginia and Oregon, but this is administratively different and diverse from our VC account. We are also members of the MetaArchive Cooperative, which is based on the LOCKSS system, which has various caches held across the country. So our 3D objects will be stored in one of these two preservation repositories in addition to our local and secondary storage. Finally, I do want to mention very briefly that our approach to 3D preservation is reconstruction. This is why we are keeping all of the elements listed in the previous slides to reconstruct the 3D objects with the technical metadata that Wen described and the raw images. Finally, objects will also be ingested into Morphosource, and this includes the crop TIFFs, all of the meshes, the texture, and select descriptive and technical metadata that adheres to what Morphosource requires. Morphosource is especially relevant to our workflow as the URLs are queried and then reconciled with SCAN datasets, which are then automatically harvested and updated to the IDIC-Bio and GBIF. So everything we ingest into Morphosource that has metadata with geographical coordinates, specifies identification, dates, and anything else associated with the collecting events is also searchable through scan and iDigBio, meaning that users should be able to facet their searches by time period to compare past and modern trends. Since the previous studies resulted in recommended practices that had not actually been implemented in practice anywhere, this is the first time to kind of observe such a system, and new challenges, primarily around scale and sustainability, have emerged from our work here. First off, the big challenge of this project lies on the data flow of repositories involved in the cycle and the lack of an automated feedback system. You can see in this diagram, there's lots of arrows pointing a lot of different ways, and it's very difficult to automate that at this point. So first, the specimen data can only be edited at the origin data source at scan. This ensures consistency, but it's disconnected with the database in terms of like a single direction data flow. Second challenge is that specimen data harvested by iDigBio and GBIF is an automated process, while the data flowing from the Virginia Tech Digital Library and the Virginia Tech Data Repository needs to be done manually. On the other hand, the technical data, metadata is mostly done manually as well, so sustainability is really an issue with substantial manual effort involved in the data management and the reconciliation. And the level of complexity, of course, increases with more involvement from more personnel and more institutions. So with that, in our next steps, we will continue to incrementally update the metadata as standards evolve, including expanding our use of the Smithsonian 3D metadata model as they finalize their elements. We're also revising metadata. We've actually discovered some missing technical metadata upon uploading to Morphosource, so this work is always and forever ongoing. As described by the previous diagram, we really want to implement an automated harvesting for at least one of the single direction data flows. This would significantly minimize processing time and make everyone's lives a lot easier. We're also staying up to date on new standards, including a new interest from the Library of Congress to develop FADGI standards for 3D production. And of course, we will continue to present to and report back to the 3D community for feedback and knowledge sharing. As we must. This project is supported by the Digitizing Hidden Collections grant. We are number 697 from the Council on Library and Information Resources. This grant program is made possible by funding from the Andrew Mellon Foundation. On a more fun note, a huge thank you to all of the people who have assisted with this grant work and its subsequent initiatives. First off, Dr. Doug Boyer at Morphosource. He played a huge role in identifying the gaps and assisted in developing our workflow and actually getting the content into Morphosource. Dr. Nicholas Paulus, who you all know as the person who solved our audio issues, but also for us, he has been the primary support in constructing and implementing the Entimo 3D grant per best practices in 3D. Dr. Paul Marc in the entomology department at Tech is our primary point of contact for specimen metadata, access to the specimens, and identifying which ones would be most ideal for 3D digitization. Maureen Savaro, who was our previous 3D technical artist and the artist behind all of the beautiful insect demos that we have shown you today. Our wonderful students, Erin, Ava, Maria, Jillian, and Tianyu. And finally, a huge shout out to the original Lib3D VR grant leaders for setting the foundation of this work. We've built a lot from their previous 2017 grant, and we couldn't thank them enough. I have just a few resources to share that Wen has brought up. They're related Entimo 3D grant work. All of them are CC BY and available for you to use and reference, and include currently our metadata schema, the Sketchfab, and our Morphosource. Soon we will have the Virginia Tech Data Repository files available as well. And because I'm trying to hurry up with this presentation so we can keep in time, we will finish up. So please enjoy this beautiful Eastern Hercules beetle, which is one of my personal favorites. And thank you so much for attending this talk. Please feel free to reach out to us with any questions and to explore the 3D insect collection, the full metadata schema, our additional presentations and all of that, which are linked in the slides, and slides will be shared in the Dropbox. So thank you so much. We really appreciate it.
Great, thank you so much. Thank you so much. So do we have any questions for Alex or Wayne? Okay, well, I'll do a little softball here, but just kind of quickly, I'm curious, obviously there's lots of different kinds of biological specimens, you know, we might make repositories for. Are there things besides meshes that might be useful in such a repository? You mentioned, you know, having the raw TIFFs, being able to maybe use future algorithms to make better models someday, or maybe the point cloud, for example, as sort of products along the way to a mesh. I'm curious if you see any potential for other kinds of 3D models in repositories like this.
So I can only speak in terms of preservation. I know that we also want to maintain the masks, but the technical metadata is really what I am relying on in terms of preservation to be able to reconstruct, because I'm all about the, in case something dies, we want to be able to maintain that in the long term. So I do think that coming up with a plan to be able to reconstruct is our best bet when we don't have the tools and expertise to emulate or be able to migrate such complex digital objects. But I will throw it to Wen, who might have a better opinion.
From my perspective is we try to save as much of metadata as possible to enable the reproducibility of the model. We try to save as many files as possible, but I'll say the metadata is relatively important as well. We do not have a standardized way of describing the metadata in a very standard way. And that is why during our uploading process, we also include the documents in describing in natural language, telling people like how are these